right, this is Craig,
This is Kendra.
and this is our presentation on the SQL programming language.
Okay, so first we want to tell you what's in store. So we're just going to give a brief overview of the structured query language, which we all know as SQL. We're going to talk about some of its uses, our experience with it, the history, its basic features, why it was invented, how it's doing now. The reason we chose this language is because we're both interested in database administration careers, and we prefer declarative languages maybe to compiled languages, right? Due to readability, writability, and some of its reduced complexity. So Craig's now going to talk about the history.
So here's the history of SQL, and we're just going to give a brief overview of how it was created, why it was created, and just some of the changes that may have happened over the years, and just a little look into the future of it. So SQL was first created through the work of Donald D. Chamberlain and Raymond F. Boyce at IBM in the early 1970s. It was created in hopes to demonstrate the feasibility of the relational database model, and they wanted to create a means of like a standardized way to manage and query databases. So, as most of us know, SQL is used for storing, retrieving, and managing and manipulating databases. So it's a very simple language that allows non-programmers to access the data. And then, as Kendra stated, it is declarative. So you just describe what kind of results you want, and the compiler figures out its own way of getting you to those results. So, like, as opposed to C++, you would have to go through the entire process. Like, you would have to tell it exactly how to do something to get what you want. And then it's a very versatile tool in the modern tech stack. Most companies use SQL or a version of SQL to manage their databases and store any kind of info that they need or data. And as SQL has advanced over the years, and it has obviously come through many, many different changes, there has been a lot of extensions onto SQL, such as T-SQL, by the Microsoft SQL Server, PL/SQL, and PostgreSQL. I don't really know how to pronounce that properly, but that's just another extension onto SQL. And so whenever SQL was first created, it had very limited functionality, but those different versions that were added onto it really allowed it to blossom and to spread out to be a more standardized tool for all businesses and companies to use. So like schools, hospitals, and things of that nature all use SQL, and there's many different ways that they are used in those companies. So a little look into the future, into how it is in present day. As of 2024, there are over 400,000 LinkedIn jobs just for SQL professionals or people who are just knowledgeable in SQL or can code in SQL. And there are even 100,000 related jobs, just anything that's even just related to SQL. There are just currently around over 500,000 jobs on LinkedIn. And then, according to the Bureau of Labor Statistics, it is to grow at a rate of 8% from the years 2022 to 2032. And according to that, that is about 10,200 jobs per year just related to SQL alone.
Okay, so now I'm going to talk about or demonstrate a brief tutorial on how to create a Hello World program in SQL. So to state, there are multiple ways to create a Hello World program in SQL. It can be as simple as you want or as complicated as you want. So we're starting with the first example. This is a MySQL example, probably the most simplest one, and it just utilizes a select and an ask statement. So basically you say select, and then you put your message in single quotes, similar to how you would do Python or Java, and then you basically select that as a message. The only thing here is that if you actually wanted to print Hello World to the terminal, you would need a select from statement. So you would have to say select this message from, whatever you want it to be, and then it'd pop up as hello. Another way you can do it, a not so popular way, is like this Oracle SQL type of way where you use a begin and end block, and you'd have to use this format dbms underscore output dot put underscore line, which reminds me of something similar to system.out print line, where you have your parentheses and then again you put your message in single quotes. And what's different between these two statements is that one initializes and basically prints to the terminal at the same time, as opposed to the first statement. And then this last one is basically a combination between the first one and the second one, where you create a procedure or a subprogram, which we'll get into later. And this particular one is called Hello World. Another begin and end statement, do your select statement, and then you'd also need a select from statement if you wanted to run this one. So that's 3 ways you can create a Hello World program, and some resources that anyone can use if they're wanting to be more knowledgeable about SQL and how it's used in database management. You can go to W3 Schools, which I'm pretty sure we're all familiar with, how it's structured. It'll walk you through every basically single aspect of SQL, and it has different examples you can use or different tools. And then there are articles. This particular one is online. It's called Learning SQL. It's a good book that we use to write our report. You can visit oracle.com, and then Stack Overflow is also a great resource.
Now, I'm going to talk about some of the basic features of SQL. So first, I'm going to talk about the design paradigm. First, I'm going to talk about key value, and it's very simple. It's just like JavaScript or a Python dictionary, where each key has a specific value, and then it stores that value in the main memory. And then wide column kind of adds on to that to where it's the same as key value, but it adds an extra dimension. So every key points to a column of values. An example of like a company that uses wide column would be Netflix. They use that to store a history of the shows that you've watched. And document based, some examples of this would be like MongoDB and Firestone, where each document contains is like a container for the key value pairs. It's non-structured and it doesn't require a schema, but each document is grouped into collections, and it's kind of like the relational design, but more into the relational design is that each column is an attribute and each row is an entity. And then each entity is recognized by a primary key, and each primary key is connected with foreign keys. But the downside of a relational schema is that it's hard to change once it's been worked on and like has had a lot of stuff added to it. You can't really go back and change the design of it. And then some of the data types, there is character, which is you're just given the size from 0 to 255. Then there's varchar, which is like it's the same as character, but instead of like a set size, it can vary. So like you can really just set like the maximum. So like an example would be like if you were wanting somebody or wanting to put the name in a name of somebody in a database. Somebody can have a 5-letter name or a 10-letter name. You don't know, but the max would be 50 as long as there's something there, then it works. And then there's binary, which the size just represents the column lengths in bytes. And there's enum and set. And then some of the numeric data types, there's bit, which stores a value between 1 and 64. Boolean and int are where the size specifies the maximum display width, and then there's floating point and then decimal where you put the size of the main number like to the left of decimal, and then you put a comma and then however many decimal points you want behind the decimal. And then here's just an example of that. Like I said, with varchar, you put the first name, it's like up to 50, but it varies, but it can't be 0. And then there's employee ID that has to be 4. And then base salary has to be a 10-digit number with 2 digits behind the decimal.
Okay, now I'm going to talk about the control flow. Basically, control flow in SQL is used to introduce logic into your queries. So it's providing this capability for you to control that logic flow. You can declare and set variables. It also is helpful in handling warnings and exceptions. And it's important to know that a lot of SQL control flow statements are nested statements. So we're all familiar with C++, and this format isn't too different. So if you look at the example on the left, I'm using a case statement, right? So this particular example if it's going to select the product name and the price, and then it has a condition. If the price is less than 10, it's going to print out it's within your budget. And then when the price is between 10 and 15, then it's going to print out mid-range, and then it's like an else statement, right? And that can go on and on. You can have multiple case statements, nested or if statements, similar to what you'd see in C++. And the one on the right is probably, it's just another way of controlling the flow of your program using an if statement and a select from statement. Expressions. So this first expression is using comparison operators. So the greater than, and then it's using logical operators to filter products that are electronics and cost more than $100. So this is a basic expression that you might see in a SQL statement when you're trying to query for something in your database. And then the one on the right is using an aggregate function. So it's using average and group by, as well as having clauses to find departments where the average salary needs exceeds 50,000. So that's a more complicated expression. Subprograms we touched a little bit on in the beginning is just this idea where SQL might have stored procedures or functions and triggers that also allows you to control the flow of your program as well. So you create a procedure or a function similar to C++. You name that function, it has something inside the procedure, and then you basically enclose it in this beginning and end statement, and you can do whatever you want in that specific block. This example is just updating the products and setting a new price, and then it's logging that price and inserting it to the database to be queried from.
And then there's object-oriented programming in SQL. Well, SQL isn't necessarily like it's not like Java where fundamentally it's object-oriented. SQL traditionally follows a relational model, but over time it has gained some object-oriented features, some modern day database systems. So an example right here would be you create a person as an object, and within that object, there's their ID and their first name and their last name. And then similar to like method declaration, you have get full name, which will return their first and last name together. And then in the member function, which was right where we get the first and get, I mean, I'm sorry, get the full name, you would do a begin and end statement and return the first name and get their last name, and then it would end as get full name. And then you create a table to get the person as the table, it would be like their first and last name. And then for exception handling, SQL and their exception handling varies across different systems. Usually, whenever there's errors in your code, you don't really see it until after it's executed. Then it'll throw an error at you. The only downside to that is that it doesn't necessarily tell you where it is. You have to go back and find it. And then for optimization, there's a lot of improvements in query performance through various techniques such as indexing, execution plans, and stored procedures. Stored procedures are basically just like methods and functions where like you can call on them later into code and they'll do whatever you have them like set to do.
Okay, so now we're gonna pull up our program, and we're not gonna go through the full thing, but we're just gonna show some of the cooler features of SQL. Okay, so this is our code. We followed a relational schema. So that consists of entities, foreign keys, and things like that. So I won't go through the full thing, but we have about 5 tables and sorry, 6 tables, and these would be our entities. And in these tables, some of them have foreign keys, and a foreign key basically means, for example, if we go to our employee table, we have a foreign key department ID, which is referencing the department table. So that is how these two tables connect. Some of the data types we used, we had bar chart, which we talked about. We have dates, decimals, where we have 10 digits with 2 following behind. Some cool things you can do with SQL code is you can specify whether you want a tuple to be not null, so it has to have a value, or if it has to be a unique value so that each value in the column is different. So then our schema goes on. We go into actually inserting data into each table. And you have to do this in a specific order because when you actually run the code, you'll get errors. Let's say if you try to insert into positions before you specified what the specific departments were, you'd have some issues with that. So relational schema is you really do have to do things in a certain way to make sure that in the end your code runs properly. So when you're inserting, you just specify the table you want to insert into here, and then you specify what values you want to insert into. So then we do that for the next couple of tables. And then we start to create some queries. So one query that we did was finding employees working on multiple projects. So you would do a select from statement where you want to select the first name of the employee, their ID, and then you want to select that from the employees table and then do a join where you're connecting the project assignments with the employee ID and the projects table. And then that'll query for something. And I'll show you on the next couple of slides what that query will come back for. And then we also had a second query as well, where we're providing comprehensive salary analysis for each department. Select the department name. We're using some aggregate functions, count, min and max, your select from statement, joining two tables. So that's basically what our code is doing. And then now I'll flip over and I'll show you what the resulting queries look like. So query one would bring up a table similar to this. We didn't really screenshot directly from Oracle because Oracle has a tendency to not be organized. But if you were to query for something like this, typically you'd get this table set up, which is in alignment with the relational sort of database schema that you see typically SQL is involved in. So that is basically our code. We tried to make it as complex as possible while trying to keep it not so complex. We wanted to make sure that we could execute everything. So these would be tuples, right? And then these would be the values and things that we inserted into each column. You query, and then it brings you back a table. So some challenges we faced was debugging in Oracle. If you've worked in Oracle or any type of SQL code, you know that Oracle will tell you something's wrong with your code, but it'll be super cryptic. It won't tell you where, and then you just have to keep going back and forth because it really likes structure and you have to do things in a certain order, especially when you're following a relational type of structure. And then, like I said, it was kind of hard to demonstrate complexity because it is an easy language, but it can get complicated. So we tried our best to find a happy medium there.
In our evaluation into SQL, we're just going to look into the difficulty and ease of use of the language. So it is a very simple language. I feel as though that anybody who new to coding or is like a seasoned professional could really learn SQL fairly quickly and just be able to just look at the language and tell what it's going to do and what it's trying to do. It's declarative, so like you just tell it what you want, and then it figures out its own way to get you the data that you want. It has English-like syntax, so there's no like really outlandish or like weird kind of
If you
syntax used
like, you
for
could
it.
literally say the sentence out loud. Like when you're reading a line of SQL code, it can literally be written in a sentence to where anybody else could understand it, even if they didn't have a programming background.
Has very simple data types, and it has great support for abstraction. So like one person can be working on a certain part of it, and someone else could, and more often than not, those two parts could be combined together with very minimal error, and then it's relationally complete or rationally complete, which means that most of the functions in SQL can be explained through relational algebra.
So now reflection, we really enjoyed doing this project because we felt like if it is something that we're serious about pursuing, we might want to know as much as we can about the different database environments and the ways SQL can be used to maybe work on some of our own projects. It helped us hone in some of our presentational skills and our writing skills. So would rate this experience probably a 2 out of no, I'm just joking. Probably an 8 out of 10, 9 out of 10. I think it was a really it was a cool project. I liked it. What do you think?
I agree with you. It's about 8 or 9. It really did help me understand the language a lot more. We did have a class over it, and I did gain a lot from that class, but doing this project has helped me really understand what SQL is, what it can be used for, and the different things that each company that uses SQL, the way they use it, and ways that it can be kind of bent and manipulated to, fulfill certain needs depending on whatever you want to do with it.
Okay. And then we provided some references and some links if you want to click on those links and check it out. We hope you enjoyed our presentation. Happy New Year.